In this lecture, we are looking at the digital I/O ports on the PIC16F877. The PIC16F877 has 33 digital I/O pins. These pins are distributed into 5 ports, and these 5 ports are named Port A, Port B, Port C, Port D, and Port E. Alternatively, the ports are named RA, RB, RC, RD, and RE respectively. Port A has 6 port pins. Port B, Port C, and Port D have 8 pins each, and Port E has 3 pins. The individual pins within the ports are named RA0, RA1, up to RA5 for Port A. For Port B, the names are RB0 up to RB7. For Port C, the names are RC0 up to RC7. For Port D, the names are RD0 to RD7. And for Port E, the names are RE0 to RE2. Each port pin may have one or more alternate function. So on the diagram, what comes after the name of the pin are the alternate functions of the pin. Each port pin can be configured to be either an input pin or an output pin. When configured as an input pin, the pin is at a high impedance input state. This state allows input devices to be connected to the port pin. The connected device can then make the pin to be either at a high voltage level, that is logic 1, or a low voltage level, that is logic 0, depending on the voltage that it is supplying. When configured as an output pin, the pin is at a low impedance output state. This state allows output devices to be connected to the pin. In the low impedance output state, the port pin can source or sink up to 25 milliamps of current. In the sinking connection mode, the output device is connected between the 5-volt supply line and the port pin. When the pin is driven low, current can flow from the 5-volt line through the output device into the port pin and eventually to the ground. When the pin is driven high, a low voltage difference is going to appear across the output device. Therefore, little or virtually no current will flow through the output device, making the device to be off. In sourcing connection mode, the output device is connected between the port pin and the ground. If the pin is driven high, current can flow from the port pin through the output device and to the ground. If the pin is driven low, the voltage difference across the output device is going to be virtually 0 volts. Hence, no current will flow through the output device, making the device to be off. For those output devices that need more than 25 milliamps, the port pin can be made to switch some switching circuit, such as a transistor switch or a relay circuit. In some cases, the port pin can switch a transistor switch, and the transistor switch in turn switches a relay circuit. Each port is associated with two SFRs. These two are a port data register and a trace data direction register. The port data register is used to write to and to read from the port. In other words, to write to a port, you write to the port data register, and to read from the port, you read from the port data register. The trace register is used to configure the directions of the port pins. In other words, to make the port pins to be either inputs or outputs. To make a port pin to be an input, a 1 is written to the corresponding position in the trace register. To make a port pin to be an output, a 0 is written to the corresponding position of the pin in the trace register. The table shows the addresses of the port data registers and the trace port direction registers. Port A data register is at address 05H. Trace A port direction register is at address 85H. Port B data register is at address 06H and is mirrored at address 106H. Trace B port direction register is at address 86H and is mirrored at address 186H. Port C data register is at address 07H, and so on, as can be seen on the illustration. In micro C programming, we set the direction of a port by assigning a value that corresponds to the desired port pin directions to the trace register. We have three statements here to illustrate this. In the first statement, the pins on the lower half of port B are set as output pins, and the pins on the upper half are set as input pins. In the second statement, all the pins on port C are set as output pins. In the third statement, pin 7 on port D is set as an input pin. To write to a port or to a port pin, we assign the value to be outputted to the port or to the port pin as is applicable. We have some statements here to illustrate this. In the first statement, we are writing the value F0 to port C. This will result in pins on the lower half of port C being driven low and the pins on the upper half being driven high. In the second statement, we are writing the value held in the variable mass to port D. In the third statement, we are setting pin 2 on port B. In the fourth statement, we are clearing pin 3 on port C. To read a whole port, we assign the port value to the variable into which we want to read. As an example, if we want to read port B, we can use a statement of the format shown by the first statement under input data. For the case of individual pins, these are normally used to select between actions. In other words, we may desire to do some action when a pin is at a logic 1 and do another action when the pin is at logic 0. This can be achieved using the if else, the mount if else, or any such other construct that is used for decision making when programming using micro C. Let's look at some issues to take into consideration when using the various port pins as I/O pins. Some of the issues may affect the operation of the port pins, whilst others may be of use and may aid us in selecting a use to which we can put a particular pin to. We shall begin with port A and port E. Pins RA0 to RA3 and RA5 on port A, and all the pins on port E are also used as analog pins. By default, when we first switch on the PIC16F877, these pins are analog pins. You will need to configure them as digital I/O pins. To do this, and for this time being, we will write the value 06H to the SFR ADCON 1. Details on how to select values to write to this register shall be covered when we go into the topic about analog to digital conversion on the PIC16F877. Pin RA4 is a Schmidt trigger input and an open drain output. That knowledge may be of use in selecting a suitable use for this particular pin. Port B. All the pins on port B have weak pull-up resistances. These resistances can be enabled or disabled in software. This is done using the bit RBPU in the option register. So you may consider a suitable use of port B is connecting input devices that need pull-up resistances. Also on port B, there is an interrupt on change facility on pins RB4 to RB7. This means that whenever any of those pins changes state, an interrupt is going to be raised. So also, you may consider some suitable uses for this kind of interrupt. Ports C, D, and E. The pins on all these ports have Schmidt trigger input buffers. Again, this knowledge is useful in deciding the devices that can be best connected to these ports.